This might be counterintuitive because they had different prices and were released in different years, but it's true. So why is this? Well, during the manufacturing process, sometimes patterning errors, dust particles, or other manufacturing issues cause damage and create defective areas of the circuit. Instead of throwing out the entire chip because of a small defect, engineers find the defective region and permanently isolate and deactivate the nearby circuitry. By having a GPU with a highly repetitive design, a small defect in one core only damages that particular streaming multiprocessor circuit and doesn't affect the other areas of the chip. As a result, these chips are tested and categorized or binned according to the number of defects. The 3090 Ti graphics card have flawless GA102 chips, with all 10,752 CUDA cores working properly. The 3090 has 10,496 cores working. The 3080 Ti has 10,240, and the 3080 has 8,704 CUDA cores working, which is equivalent to having 16 damaged and deactivated streaming multiprocessors. Additionally, different graphics cards differ by their maximum clock speed and the quantity and generation of graphics memory that supports the GPU, which we'll explore in a little bit. Because we've been focusing on the physical architecture of this GA102 GPU chip, let's zoom into one of these CUDA cores and see what it looks like. Inside this simple calculator is a layout of approximately 410,000 transistors. This section of 50,000 transistors performs the operation of A times B plus C, which is called Fused Multiply and Add, or FMA, and is the most common operation performed by graphics cards. Half of the CUDA cores execute FMA using 32-bit floating point numbers, which is essentially scientific notation, and the other half of the cores use either 32-bit integers or 32-bit floating point numbers. Other sections of this core accommodate negative numbers and perform other simple functions like bit shifting and bit masking, as well as collecting and queuing the incoming instructions and operands, and then accumulating and outputting the results. As a result, this single core is just a simple calculator with a limited number of functions. This calculator completes one multiply and one add operation each clock cycle, and therefore with this 3090 graphics card and its 10,496 cores and 1.7 GHz clock, we get 35.6 trillion calculations a second. However, if you're wondering how the GPU handles more complicated operations like division, square root, and trigonometric functions, well, these calculator operations are performed by the special function units, which are far fewer, as only 4 of them can be found in each streaming multiprocessor. Now that we have an understanding of what's inside a single core, let's zoom out